Was created by JHCP and published on Coderush. As I am still easing my way back into solving this sort of programming exercises, I am going for yet another simple one. But unlike the last time, this kata is about strings and characters instead of integers. So the input is a string that consists of only lowercase letters and may or may not contain spaces. And the expected result is the count of all vowels the input string contains. For example, let's say we get the word Coderush as our input string. The expected result would be 3, as the input string contains exactly that many vowels. And as stated before, the words can be separated, but that shouldn't change the result. So if you want to try this kata for yourself first, just click on the provided link in the description. Let's get started. First of all, I'm going to extend the test cases according to the assignment by creating a test called Test Single Vowel, where I'm going to test if all inputs with just one vowel are working as intended. Then in the second test, I will also check for inputs with multiple vowels combined. Afterwards, I actually run the tests without any code written to see if they fail as they should. And now, let's talk about the implementation itself. I was quite confident that there would be a more elegant way to solve this kata, but I did not want to Google any specific functions just yet, so I went for the simplest implementation that I could actually think of, namely just iterating through all the characters and incrementing the vowel count variable whenever the current letter that is being looked at is a vowel. Then I run all my test cases, and after they succeeded, I run the provided test cases to check if my solution is complete and submit it as my final solution. Finally, let's have a look at some of the other solutions for this kata. First, the clever ones. I always like using the LINQ library, although it can be slightly confusing at first glance if you aren't used to it. So in this solution, the count function was used, which without a parameter returns the count of all characters in this string. But in this case, we check if the provided string A, E, I, O, U contains that very letter, and only then the count function actually increases its return value. A very sleek and concise solution, especially if you are used to the LINQ way of thinking. In a very similar fashion, one could use a regular expression to count all vowels. But I am personally not a big fan of using regular expressions, as they tend to be very annoying to debug and normally grow out of proportions rather quickly sometimes. Still, it's a short and very clear solution nonetheless. Now, let's have a look at the not so clever solutions. The idea in this solution is very similar to mine, which admittedly isn't very clever either, but creating substrings, converting these to strings for no reason, and comparing those with a one-letter string, which should be a character, is kind of weird. Especially because calling the substring method 5 times instead of simply once is generating a lot of unnecessary garbage. This solution is a good example of when not to use switch statements, especially because all cases do exactly the same thing and could therefore be collapsed through cascading by deleting all breaks except for the last one. All things considered, it took me about 3 minutes and 50 seconds to complete this kata. I ran my test cases twice and submitted once. Also, I didn't have to Google anything for this one, just like last time. Thank you for watching, and if you have any questions, general feedback, or if you want to suggest a certain kata, just let me know in the comments.